Welcome to today's class. Today I am going to explain a very important topic. Generally, majority of the students will get confused by understanding this concept. The concept is definite integration as a limit of sum. Okay now. In this video, I am going to explain this concept in detailed way, right? So don't skip this video. So please watch this video until the end so that you can understand this concept very clearly. Okay now? So let us start our class. So here let us take this as x-axis and it is y-axis and it is origin. Okay. Let us take a function. So this is y is equal to f of x. Y is equal to f of x is a curve. So let us take the ordinates as x is equal to a and here x is equal to b. That means this curve or this function is defined in the limits from a to b. So that is the domain is closure bracket a to b. I want to find out the area under the curve y is equal to f of x bounded by the lines x is equal to a and x is equal to b and x-axis. Okay now, to find this area, to find this area, what I want to do is, I want to divide this total area into some strips which have equal width. That means I am dividing this area like this. See here, strips. These are all strips. So this is the strips. Okay now. Generally anybody can say that the area under the curve is nothing but sum of the areas of the strips 1, 2, 3 so on up to n strips. Let us check one by one so on. Let this first point be, so this is I am concentrating on this strip. Let the width of the each strip is h. The width of the each equal width h. This is also h. This is also h. This is also h, this is also h, this is also h. Equal number of width I have divided. Okay now. So let us see this. Let us this first point be x naught, this is a x1 and this is x2 and this is so on. This is xr, this is xr my r plus 1, so on. This is a x of n minus 1, this is xn. Okay. That means here the first point A is equal to x naught. X naught is equal to A. X naught is equal to A. X1 is equal to how much? X1 is nothing but, see here, this X1 is nothing but, here this is X1 is nothing but x naught plus h. If you add h, then you will get x1. That is means what? X naught plus h, that is equal to a plus h. X naught means how much? A plus. It is an arithmetic progression. What is your x2? Your x2 is nothing but x naught plus 2h. This is 1h, this is 1h. If you, for x naught, if you add 2h, h plus h, 2h, that means x naught plus 2h. That is a plus 2h. Understand? Last and final, x3. What is your x3? X naught plus x3 means what? Up to here, this length, x3. That means x naught plus h plus h plus h, one more h, 3h. Then you will get x3, x naught plus 3h. That is a plus 3h. So on, so on. In between rth term, that means xr is there. xr is equal to a plus rh. See, if it is a 3, you are getting 3h. If it is 2, you are getting 2h. If you are 1, you are getting 1h. 0 means no h. xr is equal to a plus r plus h. If it is go on last one, B is nothing but, what is B here? Xn. B is how much? Xn. Xn is equal to how much? See here. If it is R, A plus RH. If it is 3, A plus 3H. Bn means what? Xn means what? A plus NH. A plus NH. That means B is equal to A plus NH. From this you can say that N is equal to B minus A by H. This is the first formula you have to get. H is equal to B minus A by N. Now what is the width of the strip that you have to consider? What is the width of the strip means? Just the previously you may get one doubt. Sir, how can we take the length of the each strip is equal? How can we take the length, width of the, length is different. Afterwards I will talk about this length. I am concentrating upon the width of the each strip. The width of the each strip is given by the formula H is equal to B minus A by N. N means what? Number of strips. So here 1, 2. So if it x1 is there, first strip. x2 is there, 2 strips. x3 is there, 3 strips. Last one is what? xn. That means n strips. How many number of strips you are dividing into? You are dividing into. That is n. N number of strips. So therefore H is equal to B minus A by, H is equal to, so this is equal to, H is equal to B minus A by N. So the width of the strip is equal to B minus A by N. B is the upper limit, A is the lower limit, N means how many number of strips you want to divide. Okay, na? Right. Now what I want to do is, whatever concept is, we want to find out the area under the curve y is equal to f of x. That is nothing but area of the sum of the strips. Okay, right. If the strips are, concentrate on this first strip, If it is in the some regular shape, whether it is a rectangle or a square or whatever may be that, you can find out the easily area of the each strip. But if you observe here straight line, here it is also straight line, here it is also straight line, but the top is, the problem is with the top. It is in the curve shape. Then how to find out the area of this region? So I can call it as a region, not rectangle. So here region, why? Because here there is a curve. Okay. To make you understand this, up to here I am drawing a separate diagram. Okay, na? So let us see that diagram. Welcome back to this concept. Here observe the first strip. I am highlighting the strip like this. I am drawing a very big strip. So this is a starting is x0. This is second one, that is a second, that side is not. Now this is like this. Okay, na? Right. You want to find out the area of the region A, B, C, D. So this area you want to find out, A, B, C, D. So I am creating two rectangles like here. What is that? A, B, C, D region. So this is equal to E. Again here also one more rectangle I am creating. That A, B, C, D, E, F. You call it as F. Here there are two rectangles are there. First rectangle is ABED is one rectangle. Another rectangle is ABCF is another rectangle. There is a region ABCD, that is the region. That region area we have to find out. Okay, now afterwards I will multiply with the n number, then we will get that answer. Okay, first then how to find out. First, what I am going to do is, I want to find out the area of ABED. Okay, now ABED. See here, already we know that this is H. Right, this is H. What is the area of the rectangle? Length into breadth. What is this length AD? AD is nothing but f of x naught. Here length AD, this length I am right. Now, I am finding area of rectangle ABED. ABED. That is equal to length into breadth. That is equal to length is equal to f of x naught, breadth is h. F of x naught into h. Okay. This type of rectangles are, how many are there? This type of, so okay, we will put it like that. Afterwards, we will see that area of rectangle ABED. Now, what is the area of rectangle ABCF? Area of rectangle ABCF is equal to h into, what is this length? This length you have to write down, length into breadth. This length is equal to f of x1. This length is f of x1. That is equal to f of x1. Understand this? Okay, right. Now, coming to this type of strips are how many? There are n number of strips are there. So, if you want to find out the total area, you have to find out area of the sum of all the strips. Okay, now, right. If you take it as the area of this region as a small n, that means we know that area of ABED. Area of ABED is less than area of the region ABCD. Area of the region ABCD, which is less than area of the rectangle ABCF. Area of the rectangle ABCF. Okay, now what I am going to do is, these rectangles are there, no? For each strip it will be there, no? For each strip the small rectangle ABED is there, no? I want to find out sum of the areas, sum of the small rectangles. Let us call it as a SN. So, SN is equal to how much here you will get? First rectangle, first small rectangle area h into f of x naught, plus for another rectangle. So, this will be, that means you observe here you are taking left hand side quantity, left hand side right height you have to take, okay, for small rectangle. For the second strip, this will be the height, f of x1 will be the height, that means f of x1. Understand this, f of x1. If you go on, what is the last one here? So, this is the last one. Left hand side is equal to how much? This is x of n minus 1, this is xn, left hand side. Okay, so on, that is h into f of x2 plus so on. Last one h into f of x n minus 1. H into f of x n minus 1. Okay, now last strip. Last strip, left hand side height you have to take. Why? Because small rectangle, rectangle you have to take. Now, I will use the notation h is equal to h into, so therefore, f of x naught means what? A. H into f of x1 means how much? X1 means how much? Already we wrote a plus h. A plus h. H into f of x2 means a plus 2h plus so on h into f of a plus n minus 1 into h. Okay, now let us take h common outside. I have taken h common outside, that is f of a plus h plus f of a plus 2h plus so on f of a plus n minus 1 into h. Okay, now If you observe, these are all sum of the terms, sum of the terms. Can I use the sigma notation? Yes, I can use. How? That is equal to h into sigma. See here, what is the variable here? 1, 2, 3, so on, n minus 1. So let us call it as r is equal to 0 to n minus 1, f of a plus RH. A plus RH. Check it, both are same. R runs from 0, first you put 0, f of a, R runs from 1, 1h, 2h, 3h, so on. In place of R, put n minus 1. F of a plus n minus 1 into h. Understand this? Right. This is what area of the sum of the areas of the small rectangles. Sum of the areas of the small rectangles. Now I am going to see the sum of the areas of the big rectangles. Sum of the areas of the big rectangles. So these areas I am going to do. That means Sn I am using. This is a small sn, this is a capital Sn. Right. For this also see here, what is the area of the big rectangle? That is length. Length means how much? F of x1. What is the height? Sorry, length into breadth. Breadth is equal to how much? H. Plus, that means here you are taking, for every right angle, length you are taking right side part. Right side you are taking. Why? Because this is a big rectangle, no? Big rectangle, length is equal to f of x1, that side. That side you are taking. Next, h into f of x2, h into f of x3. Last rectangle is equal to how much? Here. That means f of xn you have to take. Last rectangle, last big rectangle, h into f of xn. Understand this? So already this I completed, sum of the areas. Now I am doing this. Okay, now so this I take h common outside, f of x1 plus f of x2 plus so on, f of xn. Okay, now right. Since this is a sum of some n terms, I can use it in the sigma notation. That is equal to h into sigma, r runs from 0 to n here. F of here how much? Sorry, before doing that, I have to convert this into in terms of a and h like this. Okay, na? So let us write this. So this is equal to h into f of x1 means how much? X1 means what? A plus h. X1 is equal to how much? A plus h. This is a plus h, f of a plus 2h plus last one f of a plus nh. Okay, now let us take the h common outside. If you take common outside, if you use the notation, r runs from 1 to n f of a plus rh. R runs from 1 to n. So here first a plus 1h, a plus 2h, a plus 3h, so on, a plus nh. F of x1, this is the area of the capital S. Sum of the areas of the big rectangles. Okay, na? So almost we came to an end. So let us continue the solution. Welcome back. So here this is nothing but the areas of the sum of the areas of the small rectangles. So this is the small rectangles. This is the small rectangles. Sum of the areas of the small rectangles A, B, E, D in each strip. In each strip, if you divide like this, you will get n number of small rectangles. So this is the area. And that side, h into sigma r runs from 0 to n, f of a plus rh is nothing but area of the big rectangle, a sum of the areas of the big rectangles. So this is nothing but area of the region. So this is nothing but area of the region AB. So under the curve, under the curve A to total area. So, this I can write down it as a integral A to B f of x dx. Integral A to B f of x dx means what? Total area from x is equal to A to from x is equal to B, total area. Now, observe here. As n value tends to infinity, as n value tends to infinity, as that means n means what here? Number of strips, rectangular strips. If as it is go on increasing, as it is go on increasing, that means this is number of rectangles are go on increasing, then the area under the curve is nothing but, as area is under the curve is nothing but the limiting value of this, understand this? That means, so here number of rectangles, that means if it is now area of the rectangle is A to B f of x dx is nothing but limit n tends to infinity, n value, n means number of strips, that means number of strips is go on increasing. This all will see here, if you go on increasing at a certain stage, the area of this rectangle is nothing but area of this region. Area of A, B, C, D, this region will be equal to area of the rectangles. This rectangle will be equal when, as the number of strips are going on increasing, this will move closer. That means the area under the curve f of x from the limits A to B is nothing but limit n tends to infinity. N tends to infinity, this is a h into sigma r runs from 0 to n minus 1 f of A r plus h. Otherwise, that also formula works. That is a limit n tends to infinity, h into sigma r runs from 0 to n f of r plus h. Understand this? So, this is the formula to find the limit of the function, limit of the sum. We call it as the limit of the sum. This is the sum. This is the sum of the areas. This is sum of the areas of the small rectangles. This is sum of the areas of the big rectangles. Okay, the sum of the areas of the small rectangles and sum of the areas of the big rectangles. Your region, we require this region A, B, C, D is nothing but area under the curve A to B f of x dx. As n value tends to infinity, as number of strips, n means what? Number of strips are going on increasing, the area of the small strips and small rectangles and area of the big rectangles, they are almost equal to the area of the curve under the curve A to B. So, this is called limit of a sum. This is a sum of the limits, understand? So, using this concept, we have a very good number of problems which were given in previous JEE mains examination. Such type of one problem is there. So, let us see that problem. Welcome to this problem. So, this was problem can be done using limit as a sum. Okay. So, then how to do this was asked in 2016 JEE mains. So, very easy problem. Let us see the solution. So, let this value be L, n tends to infinity. So, this is equal to, so here n plus 1 into n plus 1 into so on 3n. So, this 3n is nothing but n plus 2n I can write down. So, that all are in the same format. N power 2n means what? N into n into n. How many n's are there? 2n n's are there. So, each one here 2n terms are there. Why? Because 1, 2, 3, so on 2n. 2n terms are there here, n to the power of 2n. So, n's are also 2n are there. Each one n I will distribute to each bracket. That means n plus 1 by n into n plus 2 by n into so on n plus 2n by n whole to the power of 1 by n. Understand this? Okay. So, this is equal to limit n tends to infinity. Separate n. So, that is equal to 1 plus 1 by n into 1 plus 2 by n, so 1 plus, this is called as 2n by n whole to the power of 1 by n. Okay, now, so this is L. Then you apply the logarithms on both sides, that is equal to log L to the base e. So this 1 by n will come forward. So this is equal to 1 by n into limit n tends to infinity. This is a logarithm of 1 plus 1 by n into 1 plus 2 by n, so on 1 plus 2n by n. This is box. Okay, now, right. So this is equal to 1 by n into limit n tends to infinity, log a into log b into log c, log a plus log b plus log c, that you know. That is log of 1 plus 1 by n plus log of 1 plus 2 by n plus so on log of 1 plus 2n by n. Understand this? Right. And one more step, that is equal to 1 by n into limit n tends to infinity, log of. So this I will write it as a notation, that is a sigma log of 1 plus. Here what is the variable? Here n, denominator is n. So denominator is n. See the numerator 1, 2, 3, so on. So numerator is changing, that is here put r. Therefore, r runs from 1 to 2n. Understand? R runs from 1 to 2n. Check here now. 1 by n, next to 2 by n, 3 by n. Last word is how much? 2n by n. Okay, now. This can be written as, a limit of a sum. See here, r by n is there now. In place of r by n, put x. Your limits are from 0 to, so your limits are from 0 to 2 will be there. So this is equal to integral 0 to 2 log of 1 plus x dx. So this is integral 0 to 2 log of 1 plus x dx. So if you find out this integral, you will get this solution. Okay. So let us find out that integral. Welcome back. See here, if you find out the integral of this function, the problem will be over. So then how to do this? By parts formula here there. So you call it as nothing is there, put it at a 1. Take first log of 1 plus x into, what is the integral of 1? This is a x minus integral of, what you have taken outside, log of 1 plus x. What is the derivative of log of 1 plus x? That is 1 by 1 plus x. Again you have to write down this x here dx. Okay, now, so this is equal to x into log of 1 plus x minus integral x by 1 plus x. This can be written as 1 minus 1 by 1 plus x dx. Okay, 1 plus x minus 1. So this is equal to x into log of 1 plus x minus, so this is what is the 1 for 1? X minus into minus plus, this is a log of 1 plus x. Okay, now, so this is log of 1 plus x. This first term and second term we can take log of 1 plus x common outside. So here x you will 1 get, this is minus x. This is equal to upper limit, lower limit, 0 to 2 you have to do that. Okay, now apply 2 here. If you apply first 2 here, what happens here? 1 plus 2, 3, 2 plus 1, 3. So this is equal to 3 log 3. So here 2 plus 1, 3. This is also 2 plus 1, 3 log 3 minus 2. This is minus 2 minus lower limit. If you apply 0 here, 0 plus 1, 1, 1 plus 0, 1 log 1, 0, this is 0, lower limit is 0. So this is equal to log L to the base e is equal to log 27 minus 2, log of 27 minus 2. So your L value is nothing but, so your L is nothing, e to the power of log 27 minus 2. Okay, now this can be written as, this is equal to e to the power of log 27 by e square to the base e, if it is base e. This is 27 by e square. 27. So e to the power of log 27 to the base e value is equal to 27. So denominator a power m minus n, a power m by a power n e square. that is equal to 27 by E square. So, very nice problem this was asked in 2016 problem. So, with some more problems based on this limit concept, I will come before you. Only based on these limit problems I will come before you. So, until then, all the best.